This is a key to the quiz problems. So this is problem number one. And so in problem number one, we want to factor this polynomial by grouping. And so just go ahead and rewrite this over. And usually what happens, and that's not always the case, but what happens is when you have a polynomial and they ask you to factor by grouping, the first thing you want to do is to group the first two terms and the last two terms. Now, in the first two terms, if you look at those two terms here, the greatest common factor of those two terms is x squared. So we're going to factor out an x squared from that first group. And when I factor out an x squared, I get x squared times 2. X is 2x cubed, and then minus, and then x squared times 1, in this case a negative 1, will be a negative x squared. So in the first part, all I did was I factored out the GCF of the first two terms, which is x squared. And so you get this. And you can always check yourself by using the distributive property. So if you use distributive property in your mind, this is what you get back. Now over here, you have to be a little bit careful because notice that second group, the first term of that second group, there's a subtraction symbol. So really this term is a negative term. And the coefficient, rather, is a negative coefficient. It's negative 10. So what you want to do in this case is you want to factor out a negative GCF. And so in this case, the GCF of these last two terms, that last group, is a negative 5. And when I factor out a negative 5, I get negative 5 times 2x is a negative 10x. And then a negative 5 times a negative 1 is a positive 5. So if this problem is factorable by grouping, you're doing these steps correct, these two parts here, they should have a common factor. And a common factor in this case is 2x minus 1. So now what you're going to do is you're going to factor out that 2x minus 1. So I get 2x minus 1 times. And when I factor out a 2x minus 1 from that first group, I'm left with x squared. And when I factor out a 2x minus 1 from that second group, I'm left with a negative 5. Now, in terms of factoring this right here, since 5 is not a perfect square, I'm just going to go ahead and leave it as x squared minus 5. But in reality, just so you know, in terms of factoring over any type of real number, x squared, let me write it like this, x squared minus 5 can be really factored as x minus the square root of 5 times x plus the square root of 5. But for us, we were always, when we factored the difference of two squares, that last term here was a perfect square, and 5 is not a perfect square. But if you had to, you could factor this in terms of irrational numbers, which is x minus the square root of 5 times x plus the square root of 5. Okay, just to let you know. But this is the answer. You just leave it like this. So it'll be 2x minus 1 times x squared minus 5. Okay? All right, now in the second part, in problem number 2, there were 6 polynomials, and you had to factor each of those. Some were easy to do real quickly, and some took probably a little few minutes or so. So if you look at the first one, so we have x squared minus 10x plus 16. This is an easy kind because the coefficient of x squared is 1. So the best way to do that one is to do what you've probably done before, and that's to use trial and error. So in terms of reverse FOIL, so for the first, these two terms here, the first two terms, their product has to be x squared. And the only possibility that works there is x times x. All right, so we're going to put x times x there. Now, what I would do next is I would go to that last term, which is a positive 16. Now, keep in mind, the last is a positive. So what that means is that since that last term is a positive term, the signs inside those two parentheses ought to be the same. They should be the same because a negative times a negative is a positive times a positive is a positive. But you always take that middle sign. So I know also then that when I factor x squared minus 10x plus 16, I'm going to have x minus as my two factors. And then for 16, there are several possibilities. There's 8 and 2, 4 and 4, and then 16 and 1, right, whose product is 16. And so what you want to do is since these signs are the same inside those binomials, you're going to add these two numbers and see which one gives you that 10. And so this is the one that's going to work right here, 8 and 2. So I'm going to put 8 here, and it does not matter whether you put 8 here or 2 here, does not matter. Now, before you go on to the next problem, always verify this. Make sure you check mentally if what you have here is correct. So if you FOIL, you get x times x is x squared. The outer is a negative 2x. The inner is a negative 8x. And when I add them up, I get negative 10x, which is what I wanted. And then the last, a negative 8 times a negative 2 is a positive 16. So what I have here is correct. So the answer to the first one would be x minus 8 times x minus 2. All right, so that's part A for problem 2. Now in part B, so in part B, we had this problem, 2x squared plus 9x minus 5. Now this time the coefficient of x squared is not 1, all right, but it's still not a difficult problem. And the reason for that is because the coefficient of x squared 2 is a prime number, and the last term, just forget about the negative, the subtraction here for a moment, but the last term, 5, is also a prime number. So there's not that many possibilities to go through in terms of trial and error. So that's also an easy one. So we're going to go ahead and factor this as two binomials. We're going to use trial and error. And the only possibility for the first times the first being 2x squared is 2x and x. So that I know right away, right? That's easy to figure out. Now, let's go to the last term. The last term, notice, is negative. So that means that these signs in here are going to be different. One's going to be positive, one's going to be negative. So keep that in mind. But also, for the possibilities of 5, the only possibility for the factors of 5 whose product is 5 and 1. So then we're going to put 5 and 1 in here. We're going to check trial and error and see which one works. So for example, if you put 5 here, 1 here, and then you note that the last sign is negative, so these signs have to be different, and you see the middle sign's positive, an addition problem. So what that means is that the outer and the inner, if you look at the outer and the inner, which is 2x and 5x, the larger of those will take that middle sign. So that means that this is 5x, this is 2x, so I'm going to put the positive here, there, to get that positive 5x, and I'll put a negative here to get a negative 2x. But here's the problem. When you check it, the outer is a negative 2x, the inner is a positive 5x. When you add them up, 5x and a negative 2x is 3x, which is not what you wanted. You wanted 9x. So that didn't work. All right, so that's that idea of trial and error. So what we're going to do now is this. So instead, so I know that 2x and x are the only possibilities of 2x squared. But for 5 and 1, instead of putting 5 in that first polynomial, that first factor, I'm going to put 5 in the second factor. So I'm going to put 1 here, 5 here. And now look what happens. So the outer is 10x. The inner, see this right here? The outer is 10x. The inner is 1x. But now let's deal with the signs. So the sign's negative, right? So that means one of these has to be negative, one of these has to be positive. And I want the sum to be a positive 9. So that means the 10x has to be positive and the 1x has to be negative. And the only way that can happen is if I have 2x minus 1 times x plus 5. All right, and so that would be the answer to part B. So in part B, we have, for that answer, we're going to have 2x minus 1 times x plus 5. Now in part C, we have 3x squared minus 8x plus 4. So part C, 3x squared minus 8x plus 4. And again, I'm going to factor this as two binomials. The first term, the square term, 3x squared, that's easy because 3 is a prime number. So the only possibilities for that product is 3x and x. But 4 is not prime, right? So in terms of 4, I know that there are several possibilities. There's 4 and 1, and then 2 and 2, right? So we're going to have to determine which one of these is going to work. But look also what happens. So you see that last sign's positive, so that means these signs in here are the same, right? So they're both that middle sign, so they're both negative. All right, now let's talk about 4 and 1, 2 and 2. Let's see which one's going to work. Now remember, you want that middle term to be a negative 8x. So what I would do here is I would try the 2 into 2 first. So I'm going to put 2 here, and see what happens. Now let's check it. The outer is a negative 6x. The inner is also a negative 2x. And when I add them up, a negative 2x and negative 6x is a negative 8x, which is what you wanted. So there's your answer. So I get 3x minus 2 times x minus 2 for part C. So 3x minus 2 times x plus, x minus 2 for part C. All right. Now part D, we have this polynomial. So let's look at part D. So let me go ahead and write that down. So part D, we have, all right, let's see. We have this. We have x cubed minus 2x squared minus 15x. Now, first thing you have to do, remember, and we didn't have to do it all the others, because if you look at all the other parts, part A, part B, part C, the greatest common factor of every term is 1. Now, if you look at each of the polynomials, so the greatest common factor of those 3 terms is 1, the greatest common factor of those 3 terms is 1, and the greatest common factor of those 3 terms is 1. But if you look at this one, if you look at all these 3 terms, they have an x in common, right, as a common factor. So the greatest common factor is x. So what you want to do is factor out the x first. So when I factor out the x, I get x times x squared minus 2x minus 15. Now you want to factor this part now. So if you go off to the side, and that's an easy one because the coefficient of x squared is 1. So that's going to be an easy one to deal with. So x times x. And remember, the last sign is negative, so these signs are going to be different, so we have to keep that in mind. For 15, the possibilities of 15 are 5 and 3, 1 and 15. What I would do is always try the numbers that are closer together than the number line. So 5 and 3 are closer together than 1 and 15. So I'm going to put 5 here, 3 here. Now remember, the last sign is negative, right? So when I look at the outer, which is 3x, and the inner, which is 5x, one of these is negative, one of these is positive. And the larger of these, right here that I'm circling, will take that middle sign. So that means negative 5x has to be, 5x has to be negative, and 3x has to be positive in order for me to get the sum to be a negative 2x, which is what I needed. So that means then this is subtraction, and this is addition. And so therefore, that's going to go here. So I get x times x minus 5 times x plus 3. And there's your answer. All right, so that's part D. So part D, you have x times x minus 5 times x plus 3. In part E, you had these 2 terms, and notice you're supposed to recognize in this case that 4x squared minus 9y squared is the difference of 2 squares. So in other words, if I look at this, 4x squared is 2x times itself, and then 9y squared is 3y times itself. So notice the difference of 2 squares. And so then I can factor that as 2x minus 3y times 2x plus 3y. And you can always check yourself, right? So before you go into the next problem, make sure that's correct. So if you FOIL, 2x times 2x is 4x squared. The outer, 2x times a positive 3y is a positive 6xy. The inner, a negative 3y times 2x is a negative 6xy. And notice those are opposites, so that's going to add up to be 0. And then the last, a negative 3y times a positive 3y is a negative 9y squared. And when I simplify this, I get 4x squared minus 9y squared, which is what I wanted to factor. All right, so the answer to part E is 2x minus 3y times 2x plus 3y. So 2x minus 3y times 2x plus 3y. And then for part F, same thing. You're supposed to recognize that that is the difference of 2 squares right here. So 16 minus x squared. And notice I can write this as 4 times itself and x times itself. And so I'm going to get 4 minus x times 4 plus x. Okay? All right, so that is problem number 2. All right, so that was problem number 2. Now in problem number 3, So let's go to problem number 3 now. So this is problem 3. So in problem 3, it says solve the following quadratic equation using the square root property. All right, and so always follow directions. Directions said to solve using the square root property. So when I rewrite this over, and so notice I'm squaring this binomial, and the variable x only appears in the side. So the fact that it's written in this form, some expression squared equals a number, then to get that b by itself, I can take the square root of both sides. But don't forget, when you do the square root of both sides, don't forget that plus or minus. That's needed. So in this case, when I take the square root of both sides to get that expression 2x minus 3 by itself, I need a plus or minus here. And then the square and the square root undo each other. So you get 2x minus 3 equals a positive and a negative. And remember, 25 is a perfect square. The square root of 25 is 5. Now, in this case, what you're going to do next is you're going to rewrite this as two separate equations, two separate linear equations. So you get 2x minus 3 equal 5, and then 2x minus 3 equals a negative 5. And then you solve each of those linear equations. So I'm going to add 3 to both sides. So I get 2x equal 8, and then dividing both sides by 2, and then simplifying, I get x to be 4. So there's one of your solutions. Over here, adding 3 to both sides, and then combining like terms, I get 2x equal a negative 5 and 3 is a negative 2. Divide both sides by positive 2. I get x equal a negative 2 divided by positive 2 is a negative 1. So there's your solutions. So your solutions are 4 and a negative 1. All right, problem number 4. So here's problem number 4. And remember, the direction says solve the following quadratic equation by factoring. Do not use quadratic formula. You have to follow direction. Direction says factoring. So we're going to go ahead and factor this. So we have 2x squared plus x minus 3 equals 0. And notice this is an easy one because the coefficient of x squared is prime, and that last term here, 3, is also prime. And so when I factor this, don't forget to make it equal 0 because that's an equation. So you have to have equal 0 here because that's also, see, this and this are equivalent. So equal 0 equals 0. But when I factor that trinomial, I'm going to get 2x, x, and then I'm going to go ahead and put the 3 here, the 1 there. That's the way it's going to work. And the last sign's negative, so these signs have to be different. And I need a positive x when I add the outer and the inner. And the only way that can happen is if that 3 is positive and then 1 is negative. All right. And then now I'm going to use the zero factor property. I'm going to zero factor property. And so now since I've factored and I have two factors whose product is 0, then that means one of these has to be 0. So 2x plus 3 equals 0, and then x minus 1 equals 0. So that had to be your next step. And then you solve each of those linear equations. So I'm going to subtract 3 from both sides. I get 2x equals negative 3, and then divide both sides by 2, and then simplifying, 2 divided by 2 is 1. 1 times x is x, and so I get x to be a negative 3 halves. Over here, adding 1 to both sides, I get x to be 1. And so there are the two solutions for this problem. So it's negative 3 halves, comma, 1. All right, but remember the direction says factor. So you have to make sure you're factoring. Do not use the quadratic formula. Factoring was what you were asked to do. So same thing in problem 5. Problem 5, you had factoring also, right? Factoring also. But this time, notice that your equation is not in standard form. So remember, when you're going to factor, you want to use that zero factor property. And so in order to use the zero factor property, you have to have 0 on that other side. So we have to bring all these terms to one side. And then I'm going to go ahead and put them in descending order. So remember, we're going to have to add 6x to both sides. And so when I put this in descending order, I get 9x squared plus 6x minus 35 equals 0. All right, and so now I'm going to factor this trinomial. And so when I factor the trinomial, now remember, it's going to be a little bit more work for you, but because the coefficient of x is not prime, and then 35 is not prime either. But what's going to work, I think, is going to be 3x and 3x. And then for 35, let's try 7 and 5. And don't forget, that's negative, so that means these signs are different. Now, since these terms are the same, hopefully you recognize that. Since these terms are the same, it does not matter where you put the 7 or the 5. It does not matter because those terms are, the first terms here are the same. What we have to do, though, is figure out which one's negative, which one's positive. So notice the inner term is 15x, and the outer is 21, right? And so I want my middle term to be positive, and so therefore the 21 then is going to have to be positive, and the 15x has to be negative. All right, and always check yourself when you follow it out. 3x times x is 9x squared. A negative 5 times a positive 7 is a negative 35. The outer is 21x. The inner is a negative 15x, and I get a positive 6x. Don't forget to make that equal 0. And now we're going to set each of those factors equal to 0 because we're using the zero factor property. So 3x minus 5 equals 0. 3x plus 7 equals 0. And then next step is to solve each of those linear equations. So we're going to add 5 to both sides. So I get 3x equal 5. Divide both sides by 3. I get x to be 5/3. Over here, subtract 7 from both sides. I get 3x is equal to negative 7. Divide both sides by 3. I get x to be a negative 7/3. All right, and so that's it. So those two are your solutions. So a positive 5/3 and a negative 7/3. In problem number 6, you wanted to solve this quadratic equation by using a quadratic formula. All right, so always follow directions. Now notice this is in standard form. So when using a quadratic formula, remember we're going to substitute values for a, b, and c, right? And so the coefficient of x squared is 1, so that means a is 1. The coefficient of x is negative 2, so that means b is negative 2. And your constant is 5, so that means c is 5. Now remember, it's in standard form. When using quadratic form, you have to have 0 on that side. And now we're going to substitute. So x equal the opposite. Remember, this means the opposite of b. So the opposite of b, the opposite of a negative 2 is a positive 2. Plus or minus the square root of b, which is negative 2. So I'm going to put that in parentheses. I'm going to square that. So b squared minus 4 times a is 1, times c, which is 5. All of that's being divided by 2 times a, which is 1. Now remember, it's all of that. So make sure your division symbol here expands from here to here. So it extends from your 2 here to the end of the radical. Now simplifying, so you had to show the next step. So I had to see this. I had to see at least, you say negative 2 squared is 4. A negative 1 times 4, a negative 4 times 1 times 5 is a negative 20, all divided by 2. So then that becomes 2 plus or minus the square root of a negative 16 over 2. So I had to see this right here. Now I need you to recognize that the square root of a negative 16 means the square root of a negative 1 times the square root of 16. And we know that the square root of a negative 1 is the imaginary unit I. Now, so don't put no solution here. All right, I understand that has no real solutions because you cannot take the square root of a negative number, but you have learned about imaginary units. And so therefore you have to take into account, hey, I can go further with this because I know something about imaginary units. And then the square root of 16 is 4, so you get 4i. So I'm going to put 4i here. So that's 2 plus or minus 4i divided by 2. And I want you to know that all these terms here that I'm pointing to are all divisible by 2. So 2 divided by 2 is 1 plus or minus, and then 4i divided by 2 is 2i. So you could have left your answer like this, or you could have written it as 1 plus 2i, and then comma 1 minus 2i. All right, so that would be in that blank. So you could have said 1 plus or minus 2i, or you could have said 1 plus 2i, comma 1 minus 2i. All right, and then finally, problem number 7. So this was problem number 7. So you had this quadratic equation. It's already in standard form. And you still, in this case, want to use a quadratic formula. So in this case, a is the coefficient of x squared, which is 2. B is coefficient of x, which is negative 2. And c is your constant, which is a negative 1. Substituting all of this into the quadratic formula, I'm going to get x equal the opposite of b, which is, so the opposite of a negative 2 is a positive 2, plus or minus the square root of b, which is negative 2 squared, minus 4 times a, which is 2, times c, which is negative 1, divided by 2 times a, so 2 times 2. Okay, so I had to see this. Then let's go ahead and simplify the radicand. So I get 2 plus or minus the square root of negative 2 times itself is 4. I know that a negative 4 times 2 times a negative 1 is a positive 8. All divided by 2 times 2 is 4. So make sure you have a denominator in every case because you're saying equal, equal, and so on. 4 plus 8 is 12, simplifying the radicand. So I get 2 plus or minus the square root of 12 divided by 4. And notice I had to see this right here. I had to see that square root of 12 in here. Now we're going to simplify the square root of 12 because we know that a perfect square that goes into 12 is 4. So I can write this as square root of 4 times the square root of 3. 4 times 3 is 12. And I know that square root of 4 is 2, so this becomes 2 square root of 3. So then I have 2 plus or minus 2 square root of 3 divided by 4. And now you can do one of several things here. You could recognize, and let me go ahead and write it here. You could recognize this, that these numbers here that I'm circling are all divisible by 2, right? So if I divide all these terms by 2, I get 2 divided by 2 is 1, 2 divided by 2 is 1, 4 divided by 2 is 2. So then that means I can write this as 1 plus or minus the square root of 3 divided by 2. So that goes here. So 1 plus or minus the square root of 3 divided by 2. And again, if you wanted to, you could rewrite it as 2 separate solutions instead of this compact form. So you could have said 1 plus the square root of 3 divided by 2, comma, 1 minus the square root of 3 divided by 2. And so that was it. So that was the problems on that quiz. So the quiz here dealt with the chapter on factoring and solving quadratic equations, either by using the quadratic formula or by solving by factoring. All right, so that should be the, if I can find the original, the first page. All right, so that should be the key to the quiz on factoring and solving quadratic equations.